Alright, let's sketch the following graph. F of x is equal to 1 over x if x is less than 1, and negative x if x is greater or equal to 1. So this basically is a piecewise function. So piecewise function is a function that contains two or more functions that occur at different intervals, right? So we notice that the function is going to look like 1 over x if x is less than 1, and the function will look like negative x if x is greater or equal to 1. So when x is less than 1, we'll have a reciprocal function. If x is greater or equal to 1, we'll have a linear function. Okay, so we know that f of 1 cannot be a reciprocal function because this is actually excluding the 1 itself. So f of 1 should not equal 1 over 1. Okay, so that means the f of 1 should not equal 1. So the point 1 and 1 doesn't exist. Okay, so if the point 1 and 1 doesn't exist, then that tells us that there is a discontinuity at this point. Okay, so there's discontinuity at this point, and or we can think about this as a whole, right? So it's discontinuous at x is equal to 1 at this function, but we also know that f of 1 can fit into the equation negative x, so it'll look like when we plug in 1 for x, we get negative 1. So 1 and negative 1 will exist, right? So 1 and negative 1 will exist, so we basically have a point here. Okay, now as long as x is greater or equal to 1, we can use this function. So f of 2 here will look like negative, I'm going to plug in, it's going to look like negative x, so I'm going to plug in 2 for x, and you get negative 2, right? So 2 and negative 2 is a function, right? So 2 and negative 2 will look like that, right? And so forth. Like f of 3 here is basically negative, and you plug in 3 into the equation, you get negative 3. And so we'll just kind of keep going like that, and so forth, right? So you can see that there's a linear function that's being created down here, and it's going to keep going straight down, right? Now, as x is less than 1, right, we can also assess that in the domain of this function, 1 over x, right, x belongs to a set of all real numbers, but x cannot equal 0, right? So there's restriction on x, so we have to be careful with that. We can make it get smaller and smaller to 0, but it won't touch 0. So when you have restriction, this is actually implies there's a vertical asymptote. So there's a vertical asymptote when x approaches 0, and I'm going to show you that vertical asymptote by highlighting that the y-axis here is a vertical asymptote. Okay, so this whole y-axis is the vertical asymptote, right, when x is equal to 0. And because of that, the graph actually won't hit that point. So it'll get closer and closer to that point, but it'll never touch, right? Like for instance, if we plug in f of 1/2, which is less than 1, it's going to give us 1 over 1/2 for x. And we're going to get 2, right? So we're going to get 1/2, which is here, and 2. So it's going to keep getting smaller and smaller, right, until we get to a point that is closer and closer to 0, but as it does that, the function actually will approach infinity. Okay, so the function will approach positive infinity, right? So as x approaches 0, y is going to be approaching positive infinity. Okay, so that's the idea. Or you could kind of think about this using limits if you have considered a calculus course, right? But for the time being, we'll kind of not address this using limits. Okay, so that's what the function will look like there, but we can understand that x can be equal to negative 1/2, right? Which is going to give us 1 over negative 1/2, which is negative 2. So in this case, negative 1/2 is going to give us negative 2, and you can notice here that you can also approach the vertical asymptote from the left side, right? So f of negative 1 here is equal to negative 1, right? So it's 1 over negative 1, which is negative 1, right? So you notice here that you can also approach the vertical asymptote from this side as well. So, right, I'm just gonna start with that. Right, so it's gonna keep going like that. And we can kind of understand how this would work, right? Okay, so the graph will kind of look like this. Now, we can also notice here that the range of this reciprocal function is y belongs to all real numbers, but y cannot equal 0. And the reason why it cannot equal 0 is because of the fact that there is no way to make this fraction equal 0, right? You can only make a fraction equal 0 when the numerator is equal to 0. So because the numerator isn't equal to 0, y can't equal 0, the restriction on the range here is what we call the horizontal asymptote. So there's a horizontal asymptote at y is equal to 0. I'm going to highlight the horizontal asymptote. I'm going to use green to represent that. So there is a horizontal asymptote when the graph approaches x, right? And in this sense, y can never approach 0. So you can see that the graph actually will approach 0 as x approaches negative infinity. So as x approaches negative infinity, y will get closer and closer to 0, right? Also, we can understand that if you approach the vertical asymptote from the left side, right, x approaches the asymptote from the left side. I'm going to use the right side and the left side of the vertical asymptote using plus and negative. So we stated that as x approached the vertical asymptote 0 from the right side, y was going to approach positive infinity. You can see that the trace in red is going all the way to positive infinity. But if I approach x is going this way to 0, you can see that y is approaching negative infinity, right? So y approaches negative infinity. So this is just really useful to understand some of the end behaviors of this function. And we can notice here that the restrictions of one portion of the piecewise function can be applied for the whole thing. We know that if we look at the second portion of the piecewise function, the negative x, well, if you look at negative x, the domain here, x belongs to all real numbers, and y belongs to all real numbers, as long as x is greater or equal to 1, right? So we want to kind of include that, but x has to be greater or equal to 1, right? But here we have our restriction for our reciprocal, but we also here we have an interval for a reciprocal, but we also have a restriction for a reciprocal. So we have to be very careful when looking at the domain and range of the function, right? So it's very important to understand each of the individual domains and ranges of the functions that make up the piecewise function.